Hi everyone, and welcome to the Week 8 Deepen Your Learning video. This week we'll be talking about Earth's different climate states. Throughout history, Earth has had a variable climate. A lot of this variation is due to something called Milankovitch cycles, which are related to the tilt of the Earth and its rotation around the Sun. The summation of these changes are visible in transitions in Earth's temperature over time. Here we see a map of some major time periods relatively recently, and how they are altered from the Earth's average global temperature. If Earth's average global temperature is above 17 degrees Celsius, then it is considered in a greenhouse state. And if Earth's average global temperature is below 17 degrees Celsius, then it is considered to be in an icehouse state. Now we're going to look into a few of these important transitions, starting with a transition to an icehouse state during the Paleozoic period. You can probably see that there were multiple climate transitions during the Paleozoic period, but we're just going to focus on this one, where we start out in a greenhouse state and transition to an icehouse state. And part of the reason for this particular transition was the emergence of land plants. With the emergence of plants, there was a significant amount of organisms that were dying and being buried without decomposition. And because of this significant amount of carbon burial, we saw an overall transition to a cooler climate state. In other words, this important climate sink led to the overall climate becoming cooler. The next transition we'll look at is to a greenhouse state, and this transition occurred between the Paleozoic and Mesozoic periods. At the end of the Paleozoic period, when we were in an icehouse state, we rapidly transitioned into a greenhouse state at the start of the Mesozoic due to a large amount of volcanic activity. Volcanoes are a carbon source. They released a lot of carbon into the atmosphere, and thus the global temperature and global climate became much warmer. The last transition we'll look at is also to an icehouse state during the Cenozoic period. Throughout Earth's history, tectonic plates have been moving around, breaking apart, running into each other, etc. At this particular period, during the Cenozoic period, there were a lot of tectonic plates, the continental parts of the plates, running into each other. And their running into each other created a significant amount of carbon burial through the materials in the tectonic plates being buried and sometimes even being pushed back down into the mantle of the Earth. Because there was the carbon burial here, again, we saw this carbon sink that cooled the overall climate. So again, these transitions of climate over Earth's history are normal, but it's important to look at how climate is changing now and how that fits into typical climate change patterns over Earth's history. We know we're in an icehouse state currently, and so it is not unusual for coming out of an icehouse state for Earth's temperature to become warmer, but what is unusual is the rate. So this is a graph of temperature anomalies since 1880. 1880 is the earliest year on record that we have been measuring temperature, but we do have temperature measurements from much longer periods ago due to things like ice cores, etc. But the important thing on this particular graph is that our temperature anomaly, or our distance from the average, is increasing with every year, with the last 10 years being the 10 warmest years on record. In addition, our temperature measurements that we have, especially in the more recent years, are increasing 10 times faster than we would typically see temperatures increase moving from an icehouse state into a greenhouse state. In other words, this is a very rapid transition between states, which is what makes it unusual. Positive and negative feedback for the Earth's climate function a lot like a fridge. So, a refrigerator has a certain temperature that it's regulating the fridge to be at, and it will have feedback when it gets a little bit warm. It will turn on the cooling cycles so that it cools itself again. And normally, feedbacks on Earth function in that way. Another example would be if I opened the fridge door and I was looking around in there for a little while and then I shut it, then the cooling cycle would turn on. So if there's something that occurs that warms the earth up a bit, then the feedback cycles will happen to cool the earth back down. However, there are times when this can get totally out of whack. Say you open the fridge door and then it doesn't quite close all the way, so it's left open all night long. Even though it's warming up and those feedback cycles are occurring where it's trying to cool down the fridge, it's not going to be able to keep up with the fact that the door is open. And so it's going to get warmer and warmer until your food spoils. On Earth, what can happen is if there is an event or mini events that are causing the temperature to go in one way or the other, then the feedback cycles just can't keep up with it if those events keep occurring. So, for example, unnaturally putting a lot of greenhouse gases into the atmosphere very rapidly relative to the history of the Earth, and doing so over a long period of time makes it difficult for the normal feedback cycles to keep the temperature regulated.